Thank you very much. I'm quite sure that the only thing this talk will be remembered is my inability to put on the microphone, I think. I work for a small company. It's actually a spin-off of a larger research group. Yes, it seems so. Nearer, like this. We actually created this spin-off after quite a lot of independent research, especially in the field of European projects. We have done 9 European projects in the field of distributed computing, open source quality, and so on. And we started working in a field which is quite peculiar. That's the problem of IT adoption by SMEs, small and medium enterprises or small public administrations. In general, very large companies tend to be extremely tech savvy, extremely good in integrating new technology, integrating new IT in their own infrastructures. SMEs, on the contrary, are quite behind this, and in Europe it seems to be even worse than other part of the world, like the US. So, when someone of you think about a server farm, they usually think of something like this. All nice and shiny. This is, by the way, one of Google's data center. I'm quite sure that in the previous talk by Professor Tim, the idea of the Fermilab, the server farm, was something like this, maybe not white, but blue or something like that. When you go to a small and medium enterprise and you talk about, can we see your data center, you are shown something like this. If you are lucky. If not, you say, you can work here. Which is actually not that bad as it seems. They gave me a chair. The problem is that everyone now say we can sidestep all these problems and move to the cloud. No one actually knows very well what the cloud is, where it is, or whatever it does, but everyone says, oh, you don't need servers anymore. They are somewhere in the cloud. This actually is a problem because cloud is not a substitute for public cloud, which means that I don't have servers anymore. Cloud is a set of technologies and best practices and management tools and whatever, lots of things that have to do with autonomic response to change of conditions, the capability of scale more or less linearly in terms of speed, CPU, memory, disk, and price. But no one is saying that you have to have your servers here or there or somewhere else. And actually, most of the push towards public cloud for several kind of companies is simply wrong. And the reason is economics. Because the speed of improvement in terms of efficiency, price per CPU speed, price per disk, and so on, increases much faster for CPU and disk than for networking. So you are facing a choice to move everything out or to have everything in, because after a while, the speed of the CPU that you can buy with 1,000 euros, for example, is much higher than the speed that you can buy plus all the networking in the middle. I'm not the first one to notice this. Actually, I have a customer that says, oh, we want to implement a cloud, but first we have to compare with the best in the market, which is Amazon. So they asked for the price of a 4-node cloud configuration. And they've gone to the Amazon Web Service simple monthly calculator, which is very simple because the number that you get in the end is so high that usually you have to sit down and you have nothing else to see in the screen. It costs for 4 nodes, M1 extra large with 100% utilization. That is, you have your servers and you hope to have your ERP on all the time. No storage, no networking, nothing else. It costs for each node $1,522.56. But if you pay for 3 years in advance, you can have a discount of up to 50%. That's still 3 times the cost of having the same nodes in your house with replacement, with an IT technician, with power and cooling. If you make your computation, it costs something like 344 euros per month. And it runs faster. The cost of storage is another wonderful item. Storage is one of those things that actually grows like mushrooms or whatever. If you take a petabyte of storage, which is not that far from typical SMEs, most of the SMEs where we go to, they have historical archives for 10 years. There's something like 100 terabytes, 120 terabytes. That's not that far to a petabyte. If you use a wonderful infrastructure that's called Backblaze, it's a storage as a service, totally open source, even the hardware designs. They are wonderful. You store them in your home, in your own house. It costs for a petabyte something like $100,000, which is not that much. If you buy it from Amazon, it costs you a cool $2 million, which is clearly reachable by any SMEs. I want 1 petabyte. There are $2 million. The other problem is that the speed that you get from these virtual machines is usually extremely variable. Sometimes they go fast, sometimes they don't go so fast. And in general, for every situation where you have a long-running process that runs for months on, like the majority of servers inside of a company, it's simply 3 to 4 times costlier to run them on a public cloud instead of a private one. This is actually obvious. The biggest single advantage of Amazon is scalability. If you need this kind of scalability, it's absolutely the best thing you can do to go there. If you need 1,000 CPUs for 1 hour, actually Amazon is the only choice that you have. But if you need 1 CPU for 10 years, like the majority of SMEs, well, Amazon is, let's say, less optimal. And in fact, the majority of SMEs tend to have exactly the same number of servers for a long period of time. Variability in terms of new server acquired or changed by an SME in 1 year is less than 15%, which means that a company usually gets 1 new server every 2 years, hardly expanding at will. We never found an SMEs that say, oh, we got so much success that we need to increase our servers from 1 to 1,000. It may happen to Twitter. It may happen to Facebook. It does not happen to the 99.93% of the companies in Europe. It simply doesn't happen. For those companies, the best solution is a private cloud. And what we do every day, basically, is to help companies in making a private cloud based on OpenNebula. We have decided to find some, let's say, peculiar packaging. We boot everything from a USB key that contains inside the hypervisor, distributed file system, OpenNebula, a whole slew of tools for importing VMs from other infrastructure and so on. It does have a high availability mode so that if the master nodes fails, another one takes your place, and so on. So it's very easy to use because if a node fails, you take the key out and you insert it into another PC, and basically works from there. And it's based on OpenNebula. It's actually the only thing that the user sees. It sees OpenNebula. And we take quite a long time in deciding why to use OpenNebula. We have worked for a long time. For 4 years, we have done a project related to measuring software quality and measuring barriers of adoption for various software. So we have quite a long database of tools and infrastructure for doing this kind of thing. And we evaluated both the first 4 major platforms, where Martin Mikas called them the 4 sisters: OpenStack, CloudStack, Eucalyptus, and OpenNebula, and lots of minor ones. There are actually something like 50 different cloud platforms out there. The majority are one-man show or perennial beta, or they work only when the moon is high in the sky or something like that. Some are very good and do have quite a lot of followers, like Proxmox, that has a wonderful forum with lots of help and support. But in general, we can say that we can stop in the first 4 and decide which one to use. The first problem is the architecture. They implement different views of the world, different ways of interpreting the cloud. Exactly like the architecture is different from one building to the other. Building on cloud with one architecture or the other make big changes in how you limit or gives you new possibilities. OpenStack and Eucalyptus are clearly based on Amazon EC2. OpenStack started as an Amazon clone, but later decided that it was politically incorrect, so they are trying to divorce as much as possible, but the structure is the same. Eucalyptus take proud and say, we are a perfect clone of Amazon. We even run Netflix infrastructure software on top of that, and so on. So basically, you have one very big initial decision to have something like Amazon or not. In fact, OpenStack prouds itself in saying that we want to create the ubiquitous open source cloud computing platform, blah, 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 regardless of size. Everything of every size, up to Amazon scale, which was the original Rackspace intention for starting the OpenStack project in the first place. There's a problem with this. Size does matter. You don't use this to go to work each day in the morning. Try to find park in the center of London with something like this. It also takes quite a lot of fuel. Size matters. Complexity matters. Amazon has to do things in a way, first of all, for historical reasons, and second, because they have such a huge scale that they need an infrastructure placed there to make sure that everything is as automated as possible, because no human intervention is possible. But this applies only to some specific workloads. There's a very broad, let's say, view about how different virtual machines behave. You have usually kettles and pets. Kettle is the traditional cloud computing paradigm. You have a virtual machine that doesn't have a name. It just has a number or something like that. It's a node of MongoDB, or it's a MySQL replica, or it's an Apache node. If it fails in some way, if it's ill, you simply shoot them in the head. You dispose of the body, or sell to someone to it, and you spawn another one. That's very, let's say, new style. That's very cloudy. That's very whatever. The problem is the majority of servers are not like that. They are like cats. If your ERP server starts to behave erratically, you cure it. You bring it to the veterinary. You try to help them in any way. You even whisper soothing words like, don't worry, the next service pack will be better. Don't worry. The problem is that if something happens and your cat dies, actually some part of your infrastructure dies with it. And as you see here, Amazon, OpenStack, Google Cloud, and so on are designed for this kind of anonymous virtual machine replication. The idea that virtual machines are actually something that can be exchanged freely, which is important because they are working in a scale with billions of virtual machines. But, surprise, and I stole this slide from OpenStack actually, the majority of applications in the world are virtualized applications, are still traditional ones. So, to force this kind of, let's say, pet applications inside of a public cloud, you have to change a lot of things. You have to adapt a lot of things. What we wanted was an infrastructure that, first of all, was, let's say, architecturally neutral, capable of managing as well traditional applications, traditional VMs, and cloud-style VMs. We are not interested in a very large scale. our more or less unstated limit is something like 15 physical nodes. So we are not talking about creating public clouds with thousands of hundreds of virtual machines, just a few. The other aspect is that this is not going to change. The majority of applications will remain for the next 5 years. Traditional VMs. What is the traditional VMware style applications? So we are looking for a cloud computing platform that is open, simple, architecturally well understandable, easy to see the pieces, easy to manage, easy to understand, capable of loading, of managing different kind of workloads, traditional and cloudy or cloud style, and especially lean, because the majority of our customers are not that, let's say, they don't have such powerful hardware to run everything that is on the market. Just for a comparison, this is the private cloud toolkit from Microsoft. 44 gigabytes of RAM, 36 CPUs. That's more than actually the number of cores of an SME, just to start a private cloud. Then we want something simple. That's a simplified view of OpenStack. Simple. You need this if you are going to scale to millions of nodes. But actually, all these things is like trying to build a car by assembling the individual pieces. And it's actually possible. I know of some people that is capable to do so. Penguins with lots of duct tapes. In fact, if you look at several OpenStack installations, they are actually duct tape installation. You have lots of pieces glued together. You have a vendor that adds some extension to manage one thing or the other because it's still not introduced in the latest version of OpenStack, because the next one will be always better, of course. The other problem is that complexity is not only in the architecture, it's individual pieces. The Nova controller from OpenStack has 600 parameters in a single piece. Imagine all the others. This is not bashing them. Actually, they need that, because for some installation, they have to change quite a substantial percentage of them. What I'm saying is that for the majority of installation, we don't need this kind of complexity. We don't need the huge truck that I showed a few slides before. You actually need something like a city car, because what you need is something that is simpler, that is easier to manage. Just to bash at someone else, this is Eucalyptus, which is the Amazon clone. The web interface is nice and shiny and does not allow you to manage virtual machines. Only the nodes. You want to start a new virtual machine? Open the command line. It's easy. CloudStack, not depicted here, does have a wonderful, beautiful web interface. It's also a 294 megabyte WAR file. You want to change something? Good luck. We tried. It threw out so many errors that basically we left it dead. And the last point, complexity. If you look from the functional point of view, all four of them are equivalent. They do exactly the same thing, more or less. We have no Nicira controller like in OpenStack or CloudStack. Or we do, there are some features in OpenNebula, not in the other. If you look, you make a very big table with all the features, you will see that basically they are equivalent. They do the same thing. But actually, OpenNebula do it 1 order of magnitude less lines of code. Which means that you have 1 order of magnitude less bugs. And it's actually possible to go there, read the code, and understand what it's doing, which is very important. Not that you have to change it. we found the quality of the OpenNebula code to be excellent, measured by an external tool that we implemented for the Floss Metrics project, now is managed by Bitergia. And basically, the code quality of OpenNebula is on par or better than the others, especially the others. As an hypervisor, we use KVM. We had a hard time deciding that as well, because we have some people that is more Xen-oriented, some KVM-oriented. The difference in terms of performance is actually very, very little, less than 1%. We can safely say that virtualization, the hypervisor in itself, from the CPU point of view, basically does not make a difference. And you get near bare metal performance. Memory performance is different. It's much lower, but for the majority of applications, it's not that important. And as Tim said before, you can tune it. If you know the kind of hardware that you have, cache properties, you know how to deploy the operating system properly, you are able to reduce this substantially. KVM is very simple. It's advancing very fast. It does have a few properties that we discuss later. The other aspect is file systems. We are using a distributed file system that's called MuseFS on top of a local file system. We tried all of them, and we tried them in every kernel version. We took quite a lot of time. One thing that we discovered is that there is a huge variation in terms of balancing between guest and host file system. So if you have Linux VMs hosted on top of a KVM, and of course OpenNebula, my suggestion is if you can format them as XFS. XFS is a very reliable file system. It will probably be the default in the next Red Hat installation. It does have some interesting properties in terms of localization of the writes, which means that there is limited variability in terms of I/O speed when you have many competing VMs writing in the same place. So if you use XFS, you tend to have, for more or less all the kind of VMs inside, thank you, near bare metal speed. In terms of caching, if you want read speed, use cache write through or write back. If you want to have high I/O properties in terms of small read and small write, use cache equal none. Because KVM, when you do cache write through, basically does double caching of the pages. And this introduced lots of latency later on, which means that compared to bare metal here, you get something like 3 to 5 times more performance when you have a VM. It's actually faster. And we have done this test by actually having Crystal Mark inside of a VM. So the test is real because it's not, let's say, simulated. We have the Windows machine, then we formatted it. We put OpenNebula on top of that, KVM and so on. And we have done 15 days of tests. I avoid the rest of the table. We tested BTRFS, XFS, JEFS, NILFS, everything. Basically, X4 is probably the single most all-around best file system to store VMs on. And we actually have found that in the latest version of KVM, the use of QCODE2 does not give basically any loss of performance compared to RAW. So if you want to use a file system to store your data, you can do as well, use QCODE2 instead of RAW. Every kind of VM does have different access pattern, so you decide beforehand what kind of caching structure do you have. I will try to run fast because I'm nearly the end of the talk. If it's not enough, we add a little SSD device, something like 15 to 25% of the rotational media capacity, using the enhanced I/O cache. We tested all the caching strategies on the caching kernels, the drivers for the kernel, the Linux kernel that came out in the latest time. Enhance.io is not the fastest one. It's, let's say, a reasonably fast one. It does have a huge advantage. It does not use DMD driver inside of the kernel, which means that it can cache a partition, it can cache a network device, it can cache whatever you want. And you don't have to unload and load the file system or the device for it to work. You can enable and disable it immediately every time, which is quite important because we tend to use consumer-grade SSD, so they start to fail. Some little tips. Most of our users, unfortunately, use Windows. A sad issue. KVM badly interacts with Windows 7 and 8. It does have serious clock issues, which means that it loses as much as 5% to 10% of the clock time just trying to adjust its clock. This and a few other things that help in general. Some little additions. We have added the Gate 1 SSH client to the web interface of Sunstone. Since the most important tool used by our customers is the web interface, having an SSH ready is quite good. It's very fast. This one is a wonderful tool. It's called VMX-Ray. It allows you, it's a JavaScript application. It allows you to inspect a virtual machine image directly in the browser. It allows to take files and so on. A few other things we have integrated, GuestFS, so you can copy and paste file in and to the VM or change the Windows registry. S3QL is a fuse file system that mounts Amazon or Google storage, so you can import images from there. And IPOP is an overlay network used to connect nodes that are apart from one from the other. The important thing is that OpenNebula is like this, very fast. So you don't want to transform them in something like this. And so the added feature are added as virtual machines, like Guacamole, which is an interface that converts RDP into HTML5, or monitoring or whatever. On VDI, VDI is the single most requested feature by our customer. Basically, every time they start to see how easy to use virtual machines for servers, they want it for desktops. The problem is that Windows licensing is like quantum mechanics. Only two people understand that and one lies. So the best approach is you turn your desktop, you buy a license of Windows, and you bring it inside of a virtual machine. You can do it by RDP. You can do it using the SPICE protocol, which is very fast and so on, or using a gateway that's called Ultio, which is a French application that allows you to have something quite similar to Citrix. It's a presentation server. It allows you to select application and brings them to a virtual desktop. We have quite a lot of installation with VDIs. One of the problems is that when Windows starts, it like the washing machine when it does the centrifugal. So you have to help as much as possible. One thing that we have done is a small hook on running. We increase the read ahead of the rotational media for 30 seconds so that it's able to load all the sectors one after the other. And so it's, let's say, you're able to reduce the boot time substantially. Then you return it to a much lower value because a read ahead a too big read-ahead value basically interferes with the KVM queues for I/O. It adds lots of latency. It's something that you want to avoid. Applications are moving to web applications. Already, half of our customers are using more web application than non-application client locally installed application. Even Microsoft does have a web version of Office. So we started, let's say, improving the VDI of our customers by giving them a small VM. It's called EveryDesk. You can download it from SourceForge. It's very thin. It's a Linux desktop optimized for running inside of a VM. It requires only something like 90 megabytes of RAM. You basically use RDP to have local, let's say, simulated application if you need to use Windows. And for the rest, they are basically using only the browser. And the most daring of them are using Chrome OS. That runs quite well inside of KVM. You basically start a bunch of Chrome OS applications, and the user connects them by SPICE. And you just log in and password, and you get back your application, all your connections, everything. And you destroyed them at the end. Since it's mostly read-bound, most of them is totally in cache. The startup time of a virtual machine like this is something like 5 seconds. So it's nearly instantaneous. When you have something like this, you can use this one. The Perfect Thin Client, $38. It's one of those Android dongles that you use to connect to the television. You use the ASPICE client that starts on boot, $38, Wi-Fi, and basically you have everything that you need instead of your PC. It's very useful, especially for schools, where they tend to be even more budget constrained than the SME. And the other advantage is that totally solid state, which means that we have employed it in places where there are lots of dust or humidity or extreme temperature. We have a customer that uses this inside of a small metal box where during summer you reach 70 degrees. They were changing one PC per month before. Now they're using this with a little ventilator on top of it. The last slide. OpenNebula, along with KVM and lots of glue code, basically allows us to turn a bunch of PCs into something that reach easily 99.99% availability, which is unheard of in SMEs. We have a customer that never discovered that one of their nodes disappeared because the cleaning lady basically ejected the power socket. It's basically the combination of something that is extremely simple and yet powerful enough. And one of the things that I would like to send back to the OpenNebula developers is what one of our customers told us, is that this program works like a charm. It's a pity that no one else seems to know about it. So I really hope that this, being the first OpenNebula conference, will have lots of other conferences with much more advertising and publicity. Thank you very much. Any question? No. Sorry. I've got the question about having a demo of it. Actually not, and that's by design, because first of all, you will see OpenNebula, which I think probably you have already said about. And the other aspect is that I took the opportunity to provide our experience with OpenNebula and not sell anything. But I can send you an email. Anything else?
So I'm really interested in sort of like your findings for like how the various storage packages sort of apply pretty quickly. But like your storage packets, it's FS and
We use for most installations we use. The question was about our experience with the storage backends. We use the key is actually based on BTRFS. Because it does have very good properties when running from a USB key, which is a severely constrained environment. We use compression, which allows us to have quite a lot more space. And in general, it's very good at surviving sudden power loss. For rotational media, we tend to use X4 with a bunch of more or less custom parameters like delayed journal allocation, no beach, and so on. In some cases, we use BTRFS when you have to join different drives that have different properties of different sizes. That's a very good question. We found that it really depends on the distribution. We are very loosely based on OpenSUSE, SUSE Enterprise. We are a SUSE shop for many years. And we found it a good combination of reliability, and the BTRFS implementation inside is very good. It's also very good, the one included in CentOS, Red Hat, or Oracle Linux, of course, because the main developer works for Oracle. We found Ubuntu and Debian 1 to be severely lacking, severely behind, let's say, in essential patches. We hope the situation to improve with time. I would say that it may be more useful to simply track BTRFS next and pick the patches that you think are more useful for you. No, mostly in the kernel. The user space is quite important too. But in general, the majority of the, let's say, patches that appeared to correct problems in the kernel nowadays are basically already inside of BTRFS, in the kernel model of BTRFS. Performance is not as good as ext4, but its flexibility is, in my opinion, very good. Of course, the alternative will be ZFS, which is probably the most advanced file system in terms of features. The problem is that its speed is so abysmal that it's basically unusable. That's my personal experience, of course. On top of that, we use a MuseFS with 64 megabyte chunks. So actually, the kind of assistant that we have in the backend is not that important, because it's like to have lots of small raw disks. Then on top of that, there's a huge difference in terms of performance. As I mentioned before, using XFS inside of the guests is very, very, it's much better than using the traditional ext4.
No one else? Repeat the question, please.
The question was about let's say, the size of our customers, the small companies. We do have very small accountant groups, something like 10 employees, 2 or 3 servers. The largest group is a financial company with something like 15,000 affiliates. So something like 500 employees, 15,000 people using the services. We do have one large industrial group, and the biggest one in terms of number of servers is the Regional Civil Protection Agency. So we go from very, very small, 2, 3 nodes, to fairly large. We do have some healthcare providers as well.
Okay, thank you.
Thank you.